Hi everyone, welcome to the second video in the series of data centricity and natural language processing. Today we are talking about automating high quality biomolecular data labeling and we have Shashank with us who will describe the problems and the work that we do at Elucid. So starting with the problem, so as we understand that annotating data for ML applications, this is really challenging in biomedical and healthcare domain because this requires a lot of domain expertise and highly trained specialists to perform these annotations. However, there have been recent advances in ML models that demonstrate great potential for data-driven techniques in both healthcare and biomedical research. However, this potential has been hampered due to the scarcity of high-quality annotated data, especially in the biomolecular domain, and the diversity of the subfields of these domains. There have been great models like BERT, but they haven't been directly been able to be used in biomedical applications because they had been trained on English texts. Hence, models like PubMed and BioBot had to be retrained using biomedical research articles, and this lays a foundational question as to if we have to retrain models again and again, if for specific applications. Also, the need of these annotated data sets is very high and they are very costly and laborious to obtain. There have been several strategies either to increase the efficiency of label utilization or to improve the annotation process that have been proposed by the community. So today's discussion is about a variety of approaches that exist to make efficient use of labeled data using automation.
Yeah, so Prashant, we have faced similar challenges because we are in the biomedical domain, and getting those labels is costly, as well as you need significant expertise. So supervised learning is not really an answer. The pre-trained models like PubMed BERT and BioBird, basically they stop at a point, right? They are trained on MLM objective, and they are not really cannot be used directly for tagging data, which is the use case that we are seeing here, and we do extensively at Data. The problem with those models is that if you try to use them directly, then things like things which are not very obvious, like tissue or cell line, they are very difficult to tag. And also, basically, the data sets on which these models were basically um, trained on or tested on, they are not very accurate. Like GNLPB has a lot of inaccuracies as well. So we need to fine tune these data sets, but for fine tuning, as we already know, we definitely need label data. So how to generate label data is something that a lot of companies are looking into, and at a very relatively less cost. Yeah.
So one of the techniques to deal with scarcity of data, especially labeled data, is weak supervision. So weak supervision is a technique where noisy or imprecise resources are used to provide a supervision signal for labeling large amounts of training data, especially in a supervised setting. And instead, inexpensive weak labels are then employed in understanding that they are imperfect, but they can be used to create strong prediction models. So, especially, Shashank, what are the benefits of using weak supervision? And could you give us an example of that?
Yeah, so weak supervision helped us a lot in accelerating this change. accelerating this labeling process. Basically, weak supervision involves writing these labeling functions from subject matter expertise, using heuristics, using rules to get low quality, a higher amount of labels from uh, experts or even non-experts. A very good thing we saw in weak supervision was that, and actually that's a bad thing. We saw a lot of false positives that come in, but BERT, once you fine tune the data on BERT models, then basically your false positive rates goes down. That is something that we have seen, and that's a very big promise of weak supervision. But it does not. It's not a silver bullet. We learned that the hard way, and we found out that, and we'll definitely release a blog about that. We found out that for some fields it works, where basically the subword structure is enough for it to be basically for it to be recognized appropriately. But if there is a sentence level context needed for weak supervision, then it's very difficult to use weak supervision um, for these kind of things, because like you have to like use heuristics and all of those things, and that's very difficult to agree upon. So that's one problem. The second is, if you have non-ontological values, then weak supervision might not be your forte. You might be better off basically going for another option, which I'll talk about briefly, is basically using weak supervision in conjunction with active learning. That reduces the number of labels needed for training data a lot. And by a lot, I mean, assume like half of it. So let's say you earlier needed 3,000 labels to train that model. Now you'll need like 1,500 models. And that's a very good strategy to use. And we have used that very effectively. So weak supervision along with active learning, I think, is a very great combination to go for.
Yeah. Uh, Another approach that is widely used for automating labeling of data is semi-supervised learning. Semi-supervised learning, it combines a small amount of data with a large amount of unlabeled data during training. And it trains predictive models for both labeled and unlabeled data in order to obtain better models than if they were just plainly trained on supervised learning only on the labeled data that is available. So Srishant, could you tell us a bit more about semi-supervised learning?
Yeah, that's like black magic. So in terms of Jan LeCun himself, right? So he says if intelligence was a cake, unsupervised learning would be the cake, supervised learning would be the icing on the cake, and reinforcement learning would be cherry on the cake, right? So if we basically if we use only supervised learning, then I mean, like, we are just talking about icing on the cake. We're not really talking about the cake here. So unsupervised learning is the way to. It's not a new thing, by the way. Like, people have been using this for a really long time. If you have used k-means, if you have used PCA, then you used some kind of unsupervised learning. And you can actually use k-means on MNIST data, and use semi-supervised learning for for only 50 labels, and increase your accuracy by like a giant 3 or 4%, just by like doing this semi-supervised learning. So it has a very strong potential, um, and it's very interesting to see as well. So it requires you to label only a very small amount of data, and then you basically train your model and do a clustering on your embeddings in a way that basically classifies the rest of the entities around that. The biggest difficulty is in basically trying not to overfit in these things, and basically, or you don't know if you're trying to go on if you're underfitting or overfitting, it requires some expertise to basically get into that. One of the very seminal, it's not a seminal paper, but it's a very interesting paper that people have uh, in biomedical domain have recently used some kind of semi-supervised learning to do these tasks is basically SABBIRD. But that is basically you are infusing knowledge into your embeddings. Now that can sound very different than a semi-supervised learning, but it's actually a form of semi-supervised learning where you are clustering things based on vocabulary. And that is a very beautiful paper how they have done it. I would strongly recommend anyone who want to see the power of semi-supervised learning to just go and see the SABBIRD paper. And we use it very effectively for named entity normalization. So that's a very good thing to look into. But again, it's a more of a like a very it requires a lot of expertise to develop semi-supervised learning pipelines, and it's a tough thing to do. But when you do it, it's generally worth it.
Got it. Yeah, I think we'll link the paper in the description of this video. So as you mentioned before, active learning is also one of the approaches that can be used, and it is like a special case of machine learning where learning algorithm can interactively query a user to label new data points with the desired outputs. So like it is an approach of prioritizing the data which needs to be labeled in order to have highest impact to training a supervised model. And it can be used in situations where you have the amount of data is too large to be labeled and some priorities have to be made in labeling the data in a smart way. So Shashank, could you give us an example of active learning and what are the methods that it is used in?
Yeah, it's a very, like a underdog technique right now. People don't really use it. People don't believe it. But I think it has a very high potential of basically reducing the amount of data you need for your supervised learning. And not only in LLP, I mean, like you can use it for any of the uh, modeling that you do. If you are using some kind of manual curation. So yeah, so basically for us, it has been very, as I said earlier, if you combine weak supervision with active learning, that is really a very powerful technique to reduce the number of labels. And we have been able to reduce the number of labels by around half for any for our models. The one thing that you need to be very cognizant about is like for them for the kind of application that you're dealing with is the what is the uncertainty score that you will use for machine learning. Just like a loss function, you need to loss functions are also right now commoditized. You always use some kind of loss functions, but for active learning, you actually need to think about what kind of uncertainty score is better for your own application. So don't blindly follow what people are using in NLP or in any other domain. You have to basically tailor it for your own purpose. And yeah, like I mean, it's a very simple way to think about active learning is like you're prioritizing your labels. Like what do humans look at when they are really curating the data? Are they looking at more uncertain labels, or are they just like going ahead and looking into very certain labels a lot of times? And that really basically uh, that really gets into or prohibits your model to not learn about bad cases. You can also use active learning to develop a very high quality data set as well. It's not only about the model, right? And the data set will have a balance of good good examples as well as bad examples. And that can be a very great way to basically uh, generate a very high quality data set. So it's not only on the model side, but also on the data set side as well.
Yeah.
Yeah, so active learning has been very useful for us. Yeah.
Okay. And I think a continuation of this question, maybe we can talk about some of the approaches that we at Elucidata have used that have reduced our effort in manual curation process.
Yeah, so there are certain techniques like we use model assisted manual curation rather than basically uh, asking manual curators to just like blindly go fill something. So we use weak supervision to pre-fill those things and ask our manual curators to basically just change it. Our infra allows us to do that. And that itself reduces again half of the time that our manual curators actually were used to basically um, were basically spending earlier. So they spend just half the time right now. And we use weak supervision and active learning to use less and less data for our training exercises. So these are the techniques that we use, and all of these techniques are supported in our curation infra and in our curation app, and that really allows us to increase our throughput of manual curation.
Yeah. Also, Sriram, could you since we are talking about the efficiency and the amounts of resources saved, so could you give us an estimate of how much this has led to a decrease in the manual effort?
Yeah, so this has been very useful, and this has been almost like led to a at least 2x decrease in the effort. In some cases, it has been 4x, but uh, if I had to put conservatively, it has been 2x. Um, and basically the model throughput has been higher because of this.
So, since these are automated approaches, so have you also noticed a decrease in label errors by implementing these approaches?
Yeah, for sure. Because like uh, the lesser the human interaction, the lesser there are like standardization issues, and like a small space, capital letters, and all of those things, and that helps us a lot to basically reduce these kind of errors and a lot of back and forth that happens. Um, so those errors have gone down because of these, and a lot of times we also review a lot of manual curation, or sometimes our own models tell that this manual curation might be wrong. Huh. And that is a very pleasant surprise to see when that happens. Um, yeah, so we also get to see that as well. Yeah, so that has been quite useful.
Mhm. So, what would you finally, what would you like to give some advice to people who are currently using manual curation and are looking at alternatives to this?
Yeah, so I would say it's like look at data-centric approaches like active learning, weak supervision, self-supervision, in some cases data augmentation. We are not into data augmentation right now, but we'll definitely get into that in biomedical data. And all of these techniques basically go a long way to reduce your NLP model throughput as well as training. And that really helps. And it helps you to basically, and this is I mean, if you are into snorkel pipelines and all, you can also go and check. They also suggest that that leads to a 2x less effort in terms of manual curation. So, and the investment is not that huge in terms of like the compute. Your compute will actually go down. Um, so this is my advice. Just like look after and go into data-centric approaches rather than a label-first approach. In some cases, label-first approach is necessary, so you'll have to basically tweak your approach for those specific things.
Okay, yeah. So these are like some of the approaches that we can use for automating high quality biomolecular data. And Shashank, thank you for your time. And yeah.